Have you ever wondered how machines learn? What enables them to recognize patterns, make predictions, and even mimic human-like thinking? The answer lies in a revolutionary technology known as deep learning. Deep learning is a subfield of machine learning, which in turn is a branch of artificial intelligence. It attempts to mimic the workings of the human brain in processing data for use in decision-making. The primary architecture used in deep learning is called an artificial neural network. This network, much like our brain, is composed of interconnected nodes or neurons. Each neuron takes in some input, performs computations on it, and passes the output to the next layer of neurons. Sounds simple? Well, there's more to it. These networks are composed of multiple layers, each layer designed to recognize increasingly complex patterns. The initial layers might only recognize simple patterns like lines or edges in an image. But as you go deeper, the network learns to recognize complex objects or features like faces in an image or sentiments in a sentence. Now, one may ask, how does a neuron decide what to pass on to the next layer? This is where nonlinear activation functions come into play. These functions help decide whether a particular piece of information is important enough to be passed on. They add a level of complexity, enabling the network to learn from both linear and nonlinear relationships in the data. But how does the network learn from its mistakes? This is achieved through a process called backpropagation. Essentially, when the network makes a prediction, it compares this prediction to the correct answer to measure its error. It then propagates this error back through the network, adjusting its internal parameters in order to reduce the error. This process is repeated numerous times, allowing the network to improve its predictions. These internal parameters that the network adjusts are known as weights and biases. Weights determine the importance of a given input, while biases allow for flexibility in fitting the data. By adjusting these values, the network can fine-tune its predictions. So to summarize, deep learning is a powerful tool that allows machines to learn from data by mimicking the human brain. It uses artificial neural networks composed of multiple layers, each layer recognizing increasingly complex patterns. Nonlinear activation functions decide what information is important, while backpropagation allows the network to learn from its errors. And finally, the network adjusts its weights and biases to improve its predictions. Deep learning is a sophisticated field, but understanding its underlying concepts can provide us with a solid foundation to explore further. It is a fascinating world where machines continue to learn, adapt, and evolve, much like us humans.